Look up at the night sky, you see the moon, planets, and a tapestry of stars, perhaps even the faint band of our galaxy. It feels immense, like everything there is. But what if I told you that all of it, every star, planet, and galaxy, is just a tiny fraction of what truly exists? The universe we see is only the tip of a cosmic iceberg. The overwhelming majority remains hidden in the dark. This is not speculation. It's one of the most startling discoveries of modern cosmology. Decades of observation have revealed that the universe is playing a grand trick on us. All the matter we know, planets, stars, even our bodies, makes up just 5% of the cosmos. The rest is a profound mystery, dark matter and dark energy. They don't shine or reflect light, but their influence is absolute. They govern the expansion of the universe and choreograph the dance of galaxies. Our visible universe is just the intricate decoration on a much larger, darker structure. This realization forces us to reconsider our place in the cosmos. We are not made of the dominant ingredients of the universe. We are a beautiful, improbable exception. To understand the universe, we must first understand our small, shining part. Imagine the universe as a cosmic cake. For centuries we thought it was made mostly of things that shine: stars, gas, dust. But when we measured the cosmos, the recipe shocked us. The universe is made of three strange ingredients. The largest, about 68%, is dark energy, a mysterious force pushing everything apart, accelerating the universe's expansion. Next, at 27%, is dark matter. It's invisible, but it pulls things together, acting as the gravitational glue for galaxies. We know it exists because galaxies spin faster than they should and clusters hold together when they ought to fly apart. Finally, there's us, ordinary matter, just 5%. This is the stuff of atoms, protons, neutrons, electrons, the building blocks of stars, planets, and life. Everything you've ever seen or touched is part of this tiny slice. Ordinary matter gives the universe its texture, beauty, and meaning. It's the ingredient that can look back and wonder about the rest. The universe is mostly dark, but it's the small, visible part that makes it remarkable. We are the observers, the questioners, the ones who seek to understand. The cosmic recipe is humbling and awe-inspiring. We are a small part, but our curiosity connects us to the whole. The universe's mystery is our invitation to explore. What is this precious 5%? Ordinary matter. At its core, it's baryonic matter, protons, neutrons, and electrons. These particles are the building blocks of everything we know. After the Big Bang, the universe was a hot soup of fundamental particles. As it cooled, protons and neutrons formed, fusing into hydrogen and helium nuclei. For hundreds of thousands of years, the universe was a glowing fog of these simple elements. Only when electrons joined nuclei did the fog clear, and light could travel freely. Gravity then began to pull denser regions of gas together, seeding galaxies and stars. Ordinary matter can clump, interact with light, and form stable atoms and molecules. Dark matter, by contrast, cannot cool or clump into dense objects. Only ordinary matter builds the complex structures we see: stars, planets, and life. It is the creative force of the cosmos. The journey from simple particles to complex worlds is the story of ordinary matter. It is the architect of everything visible. The story of ordinary matter is one of transformation. It begins in vast clouds of hydrogen and helium, where gravity pulls gas into denser knots. As these clumps contract, pressure and temperature rise until nuclear fusion ignites. A star is born. Stars shine for millions or billions of years, lighting up the universe. Inside their fiery cores, fusion forges heavier elements: carbon, oxygen, iron. When massive stars die, they explode as supernovae, creating elements heavier than iron and scattering them into space. This stardust enriches the next generation of stars and planets. Our solar system is a third-generation system, rich in elements forged in ancient stars. The carbon in our cells, the oxygen we breathe, the iron in our blood, all were created in stars. Ordinary matter cycles through stars, building worlds and, on at least one planet, life. From gas clouds to galaxies, it is a story of cosmic creativity. We are the products of this ongoing transformation. As our understanding grew, a puzzle emerged. Half the ordinary matter predicted by theory was missing. We counted stars, gas, and dust in galaxies, but the numbers didn't add up. About half of the baryonic matter was unaccounted for, a mystery known as the missing baryon problem. The matter had to be somewhere. It couldn't just vanish. Astronomers searched for faint stars, rogue planets, and black holes, but found too little to explain the deficit. The missing matter wasn't hiding in bright, dense regions. It had to be lurking elsewhere, in a form almost impossible to see. The search became a cosmic detective story. We realized we were only looking at the cities of the universe, missing the vast countryside in between. The missing baryons challenged our understanding of the cosmos. Where was the rest of the ordinary matter? The hunt for this hidden reservoir would lead to a breakthrough. The answer lay in the dark spaces between galaxies. The missing baryons were found not in galaxies, but in the immense spaces between them. Astronomers suspected a vast, tenuous web of gas, the cosmic web, spanning the universe. Most ordinary matter never collapsed into galaxies. It remained in these diffuse filaments. This gas, called the warm-hot intergalactic medium, WIM, is a plasma heated to millions of degrees, but so sparse it barely glows. Detecting it was a challenge. The breakthrough came by observing the shadows it cast on light from distant quasars. As quasar light passes through the WIM, it leaves tiny fingerprints in the spectrum. Sensitive X-ray telescopes finally detected these signatures, evidence of highly ionized elements in the WIM. The missing baryons were found, spread thinly across intergalactic space. The cosmic books were balanced at last. Ordinary matter's true home was revealed. Ordinary matter is just 5% of the universe, but it is the part that builds, creates, and shines. Without it, the universe would be dark and sterile. Dark matter provides the framework, dark energy drives expansion, but only ordinary matter forms stars, planets, and life. It is the actor on the cosmic stage, capable of complex interactions and chemistry. Every star, every planet, every molecule of water, these are the triumphs of ordinary matter. We are the universe's way of becoming aware of itself, made of stardust from generations of stars. The 5% is where the cosmos realizes its potential. Our reality, everything we experience, is shaped by ordinary matter. The warmth of the sun, the solidity of the ground, the colors of a sunset, all are manifestations of this rare substance. Our universe, the one we care about, is the 5% universe. It is the universe of consequence, creativity, and life. The rest may be vast, but this small part is everything to us. We are the sentient part of the cosmos, able to wonder and explore. Ordinary matter is the universe's masterpiece. Even with the missing baryons found, the story is far from over. Every answer opens new questions. Why is there any matter at all? The Big Bang should have produced equal matter and antimatter, which would annihilate each other. Yet, a tiny imbalance left enough matter for everything we see. We don't know why this asymmetry exists. The details of galaxy formation remain complex and mysterious. How do black holes and supernovae shape galaxies? How do galaxies get their shapes? New telescopes like James Webb are helping us piece together the puzzle. And what are dark matter and dark energy? Their true nature remains elusive. The fate of our universe depends on these mysteries. The frontiers of knowledge are where the next discoveries await. We began by looking at the stars, thinking they were everything. Now we know they are just a sliver, a 5% exception in a universe ruled by darkness. But this rarity makes ordinary matter, and us, precious. It is the source of all light, structure, and life. We are the sentient part of the 5%, able to ask, why are we here? Understanding ordinary matter is understanding our own origins. The story of the cosmos is our story, from the Big Bang to the rise of life. When you look at the stars, you see the evidence of the universe's creativity. You are a piece of the 5%, a temporary arrangement of stardust with the privilege of wonder. Our existence is a remarkable cosmic accident, and that in itself is a wonderful thing.